Good morning students. Today we are in physics lab. Okay? We are going to perform Ohm's law. This is the setup to perform Ohm's law. As you can see, this is voltmeter. Okay? And this is milliampere. Okay? The reading is in milliampere and this is milliammeter. Okay? Now this is the circuit to perform Ohm's law. As you can see in the circuit, a voltmeter is connected in parallel and ammeter is connected in series. Rheostat for changing the resistance and battery to apply the potential difference. Okay, before starting the experiment, we have something for you. Okay, as you have voltmeter and ammeter in experiment. Okay, so both have least count. What is the least count? Least count is the minimum count by these instruments. Okay, for this, as you can see from this instrument, the division between 0 and 1 is 10, and in this the division between 0 and 100 is 10. Okay, so in case of voltmeter, 10 division is equal to 1 volt. Okay, so 1 division is equal to 1 upon 10 volt is equal to 0.1 volt. This is the least count of voltmeter. Okay, now in case of ammeter, 10 division is equal to 100 milliampere. Okay, and 1 division is equal to 100 upon 10 means 10 milliampere equal to 1 division, and that is least count of ammeter. Okay, so the least count of voltmeter is 0.1 volt and least count of ammeter is 10 milliampere. Okay, now what is Ohm's law? As most of students know about Ohm's law. Okay, so the potential difference is directly proportional to current flowing in circuit, that is V proportional to I. Remove the proportionality, V is equal to Ri or V is equal to IR. This equation is known as Ohm's law, where R is resistance. Okay. Now the written material for you is this. Okay. You start from aim of experiment, apparatus, circuit diagram, but there is no need to write the procedure. Okay, there is no need. Then you come to the observation table. Least count of ammeter you have, least count of voltmeter you have. Okay, then this table is filled with the help of apparatus. Okay, result graph on graph paper and precaution. Okay, so you write in this way. You write all the things except procedure. Okay, now come to the table. In table, first column is of voltmeter reading. Okay, another is of ammeter reading, and then we calculate the resistance. R is equal to V upon I. Students, it is informed to you that when you draw a graph between I and V, you get a straight line. Then Ohm's law is verified, otherwise not. Okay, so now we are performing the experiment. Okay students, now we are going to perform the experiment. Okay, first switch on. Okay, now you can see that the needles in both voltmeter and milliammeter deflects. So first set these needles at 0. Okay, now slowly fixed this at 0.5 volt, at 0.5 volt, and note the reading of milliammeter in milliampere. Okay, so the reading is 0.5 volt in voltmeter and ammeter reading 50 milliampere. Okay, the another reading is for 1 volt, and that is for 1 volt this is 100 milliamp. Okay, you can see from the instrument. Now for 1.5 volt, for 1.5 volt it is fluctuating but fixed at 1.5 volt. Okay, so for 1.5 volt it becomes 150 milliampere. For 2 volt the reading is 200 milliampere. For 2.5 volt 2.5 volt the reading is 250 milliampere. Okay, 1 2 3 4 5 readings are sufficient. Okay, then you can calculate the resistance by this formula. R is equal to V 0.5 upon 50 into 10 to the power minus 3 for milli. Okay, then by calculation you get 10 ohm, and from all these you will get 10 ohm. Okay, 10 ohm. Now you will draw the graph on graph paper and you will get a straight line. When you will get a straight line, Ohm's law verified. Now from graph you draw this triangle. Okay, in this triangle mark the value of delta V and delta I. Then by the formula R is equal to delta V upon delta I, you can find the resistance R. The value of this resistance and this resistance must be equal. Okay, in this way your experiment is done. Okay, now we are drawing the graph with the help of readings. Okay, so take the current on this axis in ampere. Okay, and potential means V on this axis in volt. Okay, this is roughly graph. You draw this graph on graph paper. Okay, now You mark the scale on both the axes. Then 0.5, 1.0, 1.5, 2.0, 2.5, and similarly 50 milliampere, 100, 150, 200, 250, and 300. Okay, then from the readings 0.5 you have 50 milliampere for 100, for 1.5, 150, 200, 2.5, 250 milliampere. Okay, so for 0.5 the reading is 50. So we mark the point. For 1 the reading is 100, we mark the point. For 150, for 1.5 volt the reading is 150, so we mark the point. For 2 volt the reading is 200, we mark the point. And for 2.5 the reading is 250. Join these lines, join these points, join these points, you will get a straight line. Then Ohm's law verified. Okay, now we are finding the value of resistance. Then we draw a triangle like this. This is delta V and this is delta I. The value of delta V is 2 minus 1 is equal to 1 volt. The value of delta I is equal to the value of delta I is equal to 200 minus 100 milliampere, and that is equal to 100 milliampere. Then by the formula R is equal to delta V upon delta I, you get 1 upon 100 into 10 to the power minus 3. 10 to the power minus 3 for milliampere. Okay, then you will get 10 ohm resistance. Okay, so both the results are same. By the table we have 10 ohm, by the graph we have 10 ohm. In this way your experiment is done.